sent to you from wherever you're sitting now. So today we're going to talk about one of mechanical stress. Okay. So first of all, I want to get your attention here. This is what you call a shaft. Okay. And we all know that a shaft is one of mechanical devices that transmit power. So that is a shaft. Okay. And you see there is your bearing there. This is your other bearing that you're having there. This is one of the keys. So I have 1, 2 keys. So and then here your shaft is made in EN8 material, which we found under BS 970. I think 1983. Okay, or we can call it 08M40 material. It's EN8. All right. So what's happening here? We all know that EN8 has a UTS. If it's normalized and under the limiting ruling section of 6 to 150 millimeters, okay, it has a UTS of 550 MPa minimum, right? So meaning our material, if it's put under tension test, it needs to give a minimum of 550 MPa, all right? And then they yield in MPa as 280 MPa, right? And then the elongation percentage is 16%, right? So this is what's happening. These people want to design a shaft. They want to use a shaft in their machine. They want to use it or a device that they want to use. So they want to make sure that the material that they bought to manufacture the shaft is indeed EN8. So what they do is they proceed with the test. So this is what's going to happen. What happened is from the same batch of material that was bought for for the machining of this shaft, for designing of this shaft, they take one of the portion, a portion of it, which will be given to metallurgical labs or a mechanical lab for testing. So here's how it comes. So let's say it's tested under ISO 6892-1. Okay, that's one, which means it's a tensile test at room temperature. So more or less 21 degrees Celsius. So this is what's gonna happen. So under 6892, and then the machine is to 12 millimeter. I'm talking about the machine to 12 millimeter. You know how the tensile sample looks like for testing. It's like that. Come on, it's like this. Okay, so it's like that. So this is a sample that will be taken for testing. Okay, and then it's grabbed there. It's grabbed here. It's grabbed there. Okay, it's grabbed here. Okay, it's grabbed that side by the machine. So they try to pull it. Okay, they try to pull it vertically. Okay, or whichever direction, but one of the forces goes one way and the other one goes the other way. So I have a force F1 and a force F1 prime. Okay, so they try to pull our sample and to see how much force it's gonna withstand before it breaks. Right. So we all know the graph of tensile test. It goes like that, and then bam, it breaks there. So here, what you're seeing here, this is the zone of elasticity. Okay, so when you're putting your sample under the machine, so this zone here is the zone of elasticity, which means if you can remove the loads, okay, while pulling, if you remove the loads, the material can come back, or the sample can come back at its original sizes. All right, I'm talking about the diameter, I'm talking about the length as well. Okay, so once it has reached that side, this part here that you call yield point, once it has reached the yield point, okay, so this is the turning point to the zone of plastic deformation. So this is the zone of plastic deformation. So once it has reached that spot there, even if, and then it goes this side, even if you stop the machine, the sample won't be able to return to its original sizes or dimensions. And then it goes and then that's what we call maximum load. So this is the maximum load. So this is the highest force that this material can withstand before it breaks, right? So let's say in this case, this machine was sampled according to the normalization of ISO 68992-1. It is machine to 12.58 millimeters. So the dimension is 12.48 millimeters for our reduced section. Okay, our reduced section. So that is diameter. So this is our sample, and then it goes under test. So while testing, we realize that this part the yield point is 44.28 kilonewton. 44.28 kilonewton, and then the maximum load there is 74, 74.93 kilonewton. Right, so that is the maximum load that this sample can withstand before it breaks. And then this is what's going to happen. For these people to confirm that they can go ahead with the machining of the shafts, okay, they need to make sure that after calculation, we all know that when you have to get MPa, MPa is the unit of pressure, and then pressure means force over over section or over area. So this is what's going to happen. When you try to pull this side, actually you're trying to actually reduce that part there. So if I can cut the section of that, I'm going to have thus. I can cut the section there. So you're trying to the pressure that you're putting it under this portion here. So that portion. Okay, so what happens is the weakest part is the one that's going to be attacked, is the one that's going to be exposed. So when you're measuring the sample, you're measuring the smallest sizes, because even if on your machine, it does not mean that the whole section is the same size. You know, it might happen that your tool went through in at one point and at the other point. So realize that the smallest size is 12.48. So we all know that if you have to get the area of 12.48, the area of 12.48, so the area would be 122.33 millimeters. We all know that the area equals to d squared times pi over 4. Okay, so I get to 122.33 millimeters. So now this is what's going to happen. So if you have to get the UTS to confirm that this material is the same as what it says EN8, so what you do, you take the maximum force, because UTS is ultimate tensile strength, so it's the ultimate, the most high tensile strength. So you take, so UTS equals to maximum load, so maximum load, that one over there, over the area. So what I'm having here is 74.93 over 122.33 millimeters. And then I'm getting, what I'm getting here is 613 MPa. 613 MPa. So this one here is above the minimum, which means the material in terms of the UTS is okay. So now that's not it. I need to make sure about the yield point. So now for the yield point, this is what's going to happen. So the yield point in MPa, now I take the yield strength there, which is 44.28 over 122.33. So if I have to calculate that one, so I'm getting 362 MPa. So this means that my material is fine. It is fine, but that's not it. Now I want to make sure about the ductility. Okay, and for the ductility, what I need to do, I need to get the extension. Remember, before you test this sample, it has a certain length, which I name LO. So initial length. So after you have tested it, it has elongated. Right? It has elongated. So it has gotten some other length besides LO. So here, this length is LO plus differential L. Right? So now what's going to happen is, for me to get the percentage of ductility or the percentage of elongation, I'm going to take the differential L. So this one here, okay, multiply by 100 over LO. In this case, for BS material, what you do is your initial L is given by 5.65 square root of the area. So and now this supposed to be I don't tell you that space here, but it's fine. This supposed to be 65 millimeters. So let's say your elongation, your differential elongation is 18.9 times 100 over 65. This gives me 19%. 19%. So which means then, here it's 16%. This material is 100% right. So what's going to happen is now they can take this material and go for machining. They can machine the shaft. They are okay, but they need to make sure about the chemical test as well. They need to make sure about the hardness test as well. I'm talking about hardness debris now. Okay. So remember, a shaft undergoes a lot of stress as well. I mean, as a lot of stress, which among which are shear stress, torsion stress, all of those. But in this point, I only wanted to focus on tension or tensile stress, right? So this is how it happens. And everything is done. I hope I said everything. All right, cool. So I hope that you guys enjoy this video, and if you haven't subscribed, please subscribe. And if you like to share this video so that other people might know, because this is so good for engineers, you know, for technicians, and for people who want to know more about how it happens, you know, how things are done in your life and all of those stuff. So for now, I'm gonna ask you to take care of yourself, and see you next time. Bye.